Hello, everyone. Already the seventh weekly stream that we're doing together. Already a lot of message. Oh, of course, Josiah is here today, so of course we have a lot of questions already. Let me see if I tweeted properly that we are live. By the way, if you guys wanna share also on your social media that we are live, so that we can attract a little bit more people, that would be really awesome. I took the picture of what I'm seeing, so you can take the picture of what you are seeing. I just posted. You can check on the I posted what is behind the camera. So like what I see from my perspective, what are behind here, what are the stuff around here. So, but anyway, you can if you want, you can also share on your social media that we are live. Share the link with everyone. So the tweet was good. So 3D printing science. Bonsoir, bonjour. A lot of French, today. Non-fam, hi. Thank you for joining again. Abdullah again. Josiah, great. I like that we start to have our group of people that meet up every Thursday evening. Should be Thursday evening for most of you. Josiah, I literally found out 2 days ago that printing PolyTerra at colder temperature didn't reduce strength and made the print matte but silky. Didn't reduce the stress. So PolyTerra PLA, I'm not sure if it's completely related, but PolyTerra PLA has a very specific flowing behavior. So it's like the shear thinning effect, like how to say, like toothpaste. If you have toothpaste and then you put it upside down, then nothing happened, right? It's not gonna flow out. But if you create some shear stress, shear stress, then it will start to flow out of the tube. Then PolyTerra is the same. The more pressure you put, the more shear stress you put, and the better it will flow. So maybe at low temperature there is more shear stress because it has a higher viscosity. So maybe it flows better, and at the end it compensates the fact that you print at lower temperature. Maybe that's just something that come up to my mind when you're talking about this. And matte but silky, yeah, actually that's exactly the definition of our PLA Plus. I always have difficulties to show people or to explain what is the finish of our PolyTerra PLA Plus, because it's not as matte as PolyTerra. Where is PolyTerra? Yeah, here's PolyTerra print. So PolyTerra is very matte, right? But this one it's not silk. It's not silk, but it's not matte. It's it's kind of in between. But I really like this. I really like this finish. And actually, I think the gray also comes out pretty well. You see, it's kind of in between. But the good thing is it really hides the layers. Try to go a bit closer here. You see how it prints? That's the PLA Plus. That's the PolyTerra PLA Plus. So it's a little bit more advanced formula compared to the PolyTerra PLA. Let me put this back there. Oh, nice. I just realized we have a mini version as well. But prints very well. So matte, silky matte. I don't know if that's a thing, but silky matte. Also about multicolor, what about dichromatic filament or using the same stuff doing multi-material filament? So dichromatic filament, we talked about this in the last stream. And you know what? I forgot to take my notes. I think I put it on my desk, so I will try to memorize all the topic that we're not going to talk about today. But yes, so and then or using the same stuff doing multi-material filaments. So we will talk about this after. Let me try to check if there is any other question. But the main topic today is going to be multicolor. like thinking about the different ways of printing multicolor. I remember on Polymaker Industrial website, it said Polymaker could do co-extrusion filament, so maybe CF nylon inside, knit nylon outside. Yes, that's a capability we have. Now we need to find the right filament that provide the right ability, the right features. Abdullah, I use the almost same setting, 215 with stainless steel nozzle, 45-degree bed. Are you talking about the did I miss a question from you? Oh yeah, Abdullah, what? Oh yeah, actually I missed a lot. At what temperature do you print PolyTerra? Yes, so we usually print it at 200 degree with a brass nozzle. So if you're, you said you're using a stainless steel nozzle, so 215 sounds good. I think you shouldn't have the bed. We usually, depending on what bed surface you have, 60 degree would be better for the bed, like just the glass transition temperature of the PLA, so that it stick better. But these settings should be good enough. I didn't play too much with PolyTerra on a hardened nozzle, the stainless steel nozzle. But from experience, I think printing higher temperature is always a good idea. So I think your settings should be good. Let us know what result do you have with these settings. 215. Okay, so Jose used 225, and yeah, also a hardened steel nozzle. Okay, yeah, so usually higher temperature because of the thermal conductivity reduction with hardened nozzle. Josiah again, also, which Polymaker filament would be the best suited for a high-speed, super rigid 3D printer frame? I've heard polyamide had creep issue, but PC is the next stiffest, though there is no CF. And okay, so if you're talking about what's the best material to make a printer, a high-speed printer, so you're talking about something that can hold the jerk, right? So every time it will change. Every time it will change direction at high speed. If you have, let's say, a very high jerk, so the whole printer is going to take a big stress toward like a big force towards a certain direction. So you need the frame to be very rigid. So you need those connection to handle that. So I don't think. I'm thinking about, I don't know if having a very, very stiff material is the way to go. Maybe for quality you need the whole frame to move together, right? So that there is no bending. And then you don't have any ghosting as well if you have the whole printer that move at once. So yeah, maybe a very high young modulus material would be a good solution, because I'm also thinking about all of this movement. So you may need a certain toughness to the material as well. So something that that can absorb all of this. It's not an impact, but kind of it's a sudden stress. So I think Polymax PC should be great. I don't think you need to go into a carbon reinforced PC. I think Polymax PC would already be a good one. I've actually seen a lot of Voron printer, the open printer project, and they've been using a lot of ASA. I've seen a lot of ASA version. I've seen a lot of Polymax PC version, and I've seen a few PT version. So these three apparently are good to print printers. Now it's up to you to consider whether that printer is a high-speed one or not. Nawaz Abdullah, I used the almost, okay, so I got that one. Josiah, my Prusa doesn't like leveling a cold bee. I found an unheated bed worked the best. Okay. Santiago, yeah, I was thinking I didn't see your name, so here you are. Abdullah, so okay, so I will skip the Abdullah Josiah discussion. Multicolor PolyTerra PLA, like 4. Santiago, how are you? Very, very good. How about yourself? Abdullah, blah, blah, blah. Oh, Josiah also speak a little bit of French. That's nice. Sadly, it doesn't let me speak in Chinese. Yeah. Well, my Chinese is not that great either. So, Doing fine, thanks. Abdullah, how is the finish of PLA Pro? Is it the same as regular PLA? The answer is pretty much yes. Do you remember we broke that one last time? So we printed a better version. So this is the kind of how can I do that? Yeah, like this. So this is the it's similar to well, we still have the problem of no layers, which we need to fix, but overall it prints like regular PLA. How can I? Do I have some regular PLA out there? I think all of these are PLA Pro. Yeah. It prints like regular PLA, but just the fact that I guess it flows much better, so it kind of maintained like a very, very nice extrusion width. So I think that's the main reason why there is some kind of stuff on Twitter that we have a very bad batch of PLA Pro that print without the layer lines, which is a joke, of course. But yeah, so that's all these prints are PLA Pro, and you can see that they all come out pretty smooth. So same as regular PLA in terms of effect, but by experience it prints much smoother than the regular PLA. All of these there. Well, it's right behind me, so you cannot see so much, but all of these are printed with PLA Pro. Next was also, is there a filament good for printing fast? Theoretically, PolyTerra PLA is actually the one that should be pushed to on the highest speed. Yeah, theoretically. Actually, we do have a modified formula of PolyTerra PLA specifically for high-speed printer. But the PolyTerra PLA that we release as PolyTerra PLA should already have a pretty interesting high-speed performance. But you have to push it very hard. It's like we were talking about the shear thinning effect. So it's theoretical. Well, half theoretical, because I did experience high-speed printing. But normally you can push it as hard as you want, and it will flow. It will flow properly. So you can try. But you do need the hardware behind. You do need a high torque extrusion gear. Brian Vines, nice to see you again. Hello, 3D printing friends. We have what do we have? People saying hello to each other. That's awesome. I wish I could share photos of the PolyTerra result. Were pretty much immaculate. Yeah, I mean the matte finish of the PolyTerra really gives that. Let me take that. Do you remember last time we talked about all of these army colors? And you can see, I mean, the finish is just awesome. And I think that's mainly because of the matte effect. You can see I try to reflect the light. You see, you can barely see the layers, or everything is really nice. Let me try to take another example there. This is another army color, and even the underside. You see the where there is the layers. So it's pretty nice. But please share. You can go on our Reddit community. There is a link in the description of this live stream of our Reddit. I'm not very active at the moment on that Reddit, but we are slowly trying to grow the community. But the more you share on this, and the better you will attract people, and people want to see a little bit what you guys are printing. So, and then once I will be able to share my screen and then show it to you, then we can just scroll through all of your guys' print, and then we can comment, and then we can troubleshoot some issue that you guys have. So please share as much as you can on our Reddit community. Good thing I have a spool of Polymax PC from like beginning of 2021. Okay, shouldn't be an issue. If it was if it was sealed, then shouldn't be a problem. I'm just waiting to have the local reseller to sell Polylite PLA Pro. How much does Polylite PLA CF deform at 100 degrees for annealing? I don't think you can check. Actually, for CF, we just finished the TDS, so you can go on our us.polymaker.com, and then you go to PLA CF, and then you will have the TDS with the HDT. And annealing, we haven't done some tests. I don't think you can anneal PLA CF. It will result the same as regular PLA. It does provide better HDT, but it does not provide better heat resistance in order to help the annealing. PolyTerra also feels like ABS. Yeah, like we did last time. You know, when we broke that one, do I have ABS? I don't have ABS, but this is PolyTerra PLA. And remember, when you bend it, then you go all the way, and then it doesn't break at all. You can see it. You see, it doesn't break. And then it comes back to here, and then I can go all the other way around. It's very oh, not this time. Yeah, it broke here. I think last time it broke after more, no? I go back the other way. Oh yeah. Well, not this time. Maybe because it's very cold here. But yeah. You see the white stressing, the stress mark, the whitening, the stress widening. Yeah, stress widening. So it's pretty much like ABS, but in this case, I think it didn't really behave. I don't know why. Maybe the print or maybe the temperature. Actually, you know what would be interesting is because it's pretty cold here, so I want to see how it form. Usually the best one is Polymax PLA. Do I have any? Yeah, I have Polymax PLA. So let's see how it behaves. Because I mean, I can feel even if I touch them, they're cold. But let me check if it's the same for Polymax PLA. So it's already pretty hard to bend, much harder than PolyTerra PLA. I can see some stress marks already. Okay, so it didn't break, and then I'll go the other way. Usually the other way requires more force, and then it doesn't break. Yeah, okay. So Polymax PLA doesn't seem to be affected by the fact that it's very cold. It doesn't break, right? Then if I twist it a little bit, yeah, then it breaks. So yeah, that's very interesting. Maybe maybe we should do some tests like depending on the temperature, because you know we know that the temperature we explained last time, right? We know that the temperature is going to make filament more brittle. You know, it's going to freeze that polymer even more, and then it will increase the modulus of the material. It will make it more rigid, but it will also reduce the amount of stress they can take before they just fracture. So yeah, interesting that the PolyTerra PLA behaved that way, because we already broke 2 or 3 specimens, and it was much different than today. So it seems to be much more affected by temperature. Let me try PLA Plus. So this is the same base formula, but modified to have a better layer adhesion. PolyTerra PLA Plus. So let's see if this one is also affected. By temperature. Last time, if I remember well, that one behaved a little bit more like what? I don't remember. I think it behaved, well, theoretically it should behave like in between PolyTerra PLA and Polylite PLA, in between there. So I should be able to go all the way without breaking, theoretically. Okay, and then I go the other way. Okay, yeah, so it looks like the PolyTerra PLA formula, the base formula, is somehow affected by temperature. I actually just discovered that today. Maybe because I just put the heater just when I arrived, and I arrived just before the stream, so they were here the whole night, and it was pretty cool. Oh, but then it splintered. So you see. So yeah, that's interesting. So if you guys have, I don't know, some kind of application that requires impact resistance at low temperature, maybe go for the Polymax PLA, or the Polylite PLA, or the let's see how the PLA Pro does, because yeah, let's see. The PLA Pro should bend all the way, and then requires a lot of force, and then a lot of force to come back and then break. So normally I should be able to go the whole way without breaking. Oh, interesting. Oh, so I do think the temperature is making something. Let me try some other. This is Polylite PLA. So Polylite PLA should break, but let's see if it breaks earlier than last time. Okay, it was. I think it was similar than last time, but I could feel that much more force to break it. Yeah, that's very interesting. You know what I'm going to do? I'm going to ask R&D if they could do some like some kind of test, like tensile strength, impact strength, and bending strength. Just these three, and then maybe at low temperature. I mean, low temperature, like 5 degrees or something like this, because yeah, it's very interesting how it behaves. I don't know what you guys think, but compared to last time where we did this test a couple of times and it always behaved the same, and just today where I want to show it again, they behave a little bit differently. So I don't know if it's because I did it quickly, so I put the force a bit quicker. Last time I was a little bit slower, or it's really because of the temperature. But very interesting, a small discovery that we made today. Okay, so let me go back a little bit. Where was I? I wish I could blah, blah, blah. I was just waiting, blah, blah, blah. PolyTerra also feels, yeah, okay. PolyTerra also feels like ABS. Well, today, maybe not too much. But you know what would be great? Is next time I will try to have an ABS. And then I will see if at that temperature it would behave the same. Then we have something that really behaves the same. Santiago, it shrinks about the same as regular PLA, a bit less warping, but it still shrinks. For PolyTerra PLA, okay, that's interesting. So you mean that the CTE, the coefficient of thermal expansion of PolyTerra PLA is similar to ABS. So that means you're saying that it's different than regular PLA. Yeah, I don't have that data, but that's interesting. Josiah, both ASA and PolyTerra works well so far, but my Prusa isn't fast enough. Okay, so you also use PolyTerra for printer parts. That's also interesting. I just got PolyTerra PA Plus yesterday. Who is this? Siop. Is that how you pronounce Siop? I think I've never seen you on the stream, so very welcome to Siop, to our weekly stream. He just dived into Polymaker product with a PLA Plus, a PolyTerra PLA Plus. Siop, again, it is amazing. I just printed a bench sheet. The quality is great, and the filament is very durable. Yeah, that's very good to hear. Very good to hear that you've been introduced to Polymaker product with good experience. Try to print. I don't know which color you have, but this is the blue one from PLA Plus as well, PolyTerra PLA Plus, and the blue one and the gray one are. So we have all the color here, but the other one don't have that. Well, I shouldn't show white, but the other one has that silk effect. You see the blue and the gray. The other one a little bit less. For example, the red one doesn't have that. A little bit that silk. Well, quite a bit actually. So I don't know what kind of effect. If you have seen that matte / silk effect on your print, but yeah, PolyTerra PLA Plus is a pretty interesting material when it comes to very nice surface finish. Santiago, PolyTerra never warps. Oh, Josiah against Santiago. Okay, so I guess it depends on a lot of factors. Like we discussed, we had the whole stream on warping, right? So So we should understand pretty well now where that come from. Brian, how's things? Things are going very well. Actually, today is the last day, the last working day of this year, the Chinese year, and next week is the Chinese New Year, the holidays, and then we will come back a week after. So currently in China, that's the vibe. The vibe is like very relaxed, holiday time. We have that's the biggest holiday in China. When annealing, I think you asked. Oh, okay, warping. Oh, okay. So PolyTerra warps when you anneal it. Is that what you mean? Chris Polk, I'd love to hear your thoughts on glass and CF field composite. Yeah. So Chris Polk, I don't remember your name from before. So very welcome to our weekly live stream. So it's very easy. CF and GF have enhance the same properties, so they enhance the modulus of your materials. It provides a much higher modulus, much more rigidity, and it also bring your HDT higher. So it will. So it's related, right? It's related to the rigidity. What's the main difference? Is there is two main differences. The first one is CF can also provide ESD property. To prevent electric discharge, to evenly spread the charge on your parts. That's GF cannot do. And the second one is price. So you can see GF as the little brother of CF. So that's a simple way of showing the difference between the two. They both increase the same, enhance the same properties. CF enhance the properties much better than GF. So your modulus, if you add 10% of CF and 10% of GF, the 10% of CF will have a much higher modulus than the 10% of GF. But the price of GF will be much lower than the price of the CF reinforced material. And then again, the other difference is that the CF material can have some interesting ESD property. So in short, that's what I would say regarding glass and CF field composite. So I don't know if your question was what's the difference, or if your question was what do you think about non-reinforced material and reinforced material. If that's the question, then I think reinforced material are interesting in the way that they enhance all the different property of the material. Now the really challenge that we have to solve for 3D printing is the layer adhesion. The fact that the fibers really decrease the overall bonding strength of the parts can actually play against having a reinforced material. The non-reinforced one will have a more more solid. You will have a better chance of having a close to isotropic strength on your part. So depending on your need, if you only need an XY strength, then I think the reinforced material are very good. And actually, the continuous fiber have crazy strength. I still remember visiting during a show. Who was it already? Anisoprint. I think it was Anisoprint with their parts. It's like a continuous fiber, and they were crazy rigid. So I didn't try. We couldn't try the Z, whether it delaminate easily. But I think they found a good way to solve that problem as well. Another part is I don't know if you've tried, but if you have some CF parts, then the finish is just amazing. Like it's a little bit like PolyTerra. PolyTerra has a very matte finish. Well, the CF, all these CF infused polymer also have this very nice finish. Actually, our best. Our best. No, that's CF PLA. Yeah, I don't have the PA12 here, but our highest quality, highest surface quality finish material that we have is PA12 CF. When you print PA12 CF, you have that. I mean, it's like injection molding part right off the printer. Really excellent, excellent surface quality. Chris Polk, yeah. So Josia, I mean, different word, blah, blah. Santiago, I was answering a question you asked. I'm just waiting to have the local reseller to sell Polylite PLA Pro. Also, how much does Polylite PLA CF deform at 100 degree for any? Okay, so you're answering Josia, right? Can you complete? Abdullah, can you complete the warp-free technology discussion if times allows? The warp-free technology, is there anything I didn't say about it? Let me think. Okay, so I don't remember, but let me explain again. So the warp-free technology, do you remember our nylon? So the nylon warps not for the same reason, not for the internal stress. I mean, a little bit about the internal stress, but the main reason why a nylon part will warp is because of the crystallization behavior. You will print layer by layer, and then each layer will crystallize so fast that they will all shrink a little bit. They all shrink. So not because of the internal stress, not because of the polymer that has stretched and then come back to shape, more because all the polymer will crystallize, so they will take less space, and then each layer will shrink one by one, and then all of this induced stress by the shrinkage will basically make the part warp. So an idea would be to slow down the crystallization rate, right? So that when you print a layer, then it doesn't crystallize. You print another layer, still doesn't crystallize. After you print a lot of layer, then it will slowly crystallize. And then the benefit of this, the first one, it doesn't induce differential stress, so it doesn't warp. And the other benefit of our warp-free technology, which slow down the crystallization rate, is the crystal is going to grow from a layer to another layer. So you can have big crystal within two different layers, and that really increase the layer bonding. So our warp-free technology is slowing down, like controlling the crystallization behavior of our semi-crystalline material. So all the nylon material, all the polymide family. So I don't remember what I didn't say last time, but hopefully that completes the warp-free technology explanation. If not, then you can just ask the details you're looking for. Oh, I'm missing a lot of chat. Where was I? Sorry, I'm scrolling up. I was yeah. Let me try to answer a little bit quicker, because we still haven't started our main topic, which is multicolor. It prevents crystallization during the print, which cause. Okay, thank you, Santiago, for answering. Hello, everyone. Stephen Paul, yeah, I remember your name. Well, welcome again to our weekly stream. Josia, controls it, is more even, causing no warping. Okay. Yeah, that's great. Now I have a bunch of people that have so much knowledge that they can just answer all the questions. So you know what I could do is some kind of, I think there is a tool. We can have like some mods, like moderators in the chat, and then they can help, answering. So if there is anyone, I don't know how to do that yet, but if there is anyone interested in becoming I don't know, some kind of polymaker scientist as well, like polymaker scientist, if you want to become one of these guys and then help me to answer all the polymer question, then we could introduce this kind of idea. The same in the Reddit community, that's the goal. I'm doing this 1 hour in order to answer as much as possible, but hopefully we will have a kind of community that people can answer each other, so that people can have an answer much faster. Would there ever be a nano-reinforced nylon filament? No, for the same reason why we won't have nano-reinforced ABS of ASA, like we discussed last time. The nano-reinforcement technology bring the material to an absolute value. You cannot double, it's not like relative to the toughness of the material. You cannot enhance the toughness in a way that you multiply by 2. You can just bring it to a certain level, but if it's already at that level, then even adding the nano reinforcement won't help. So nylon is already a very tough material. So it wouldn't help. Abdullah, yes, I meant the discussion we started 2 sessions back, which was why only PLA family has warp-free. Oh, no. So Abdullah, be careful. Warp-free technology is for the semi-crystalline material. So that's for nylon. That's for our Polymite Copier, Polymite PA6GF. What you're talking about now, I remember, is the jam-free technology. So I know we have ash-free, layer-free, warp-free, jam-free. We have a lot of free. We are trying. I mean, our mission is simplify creation. So we have to get rid of all the problem. We have to create problem-free technology. But anyway, so what you're talking about is jam-free. So jam-free is increasing the crystallization degree of our PLA filament in order to make them more heat resistant, so that when it goes through the hot end, it won't melt too early, it won't soften too early and jam your printer. So that's the main reason why we call this the jam-free technology, and why silk doesn't have the jam-free technology. The main reason is that the jam-free technology has increased the crystals into the material, and the problem is that the technology we are using in order to make the silk finish doesn't really like the crystal domain in the filament. So it will go. So you won't have a good mixture between the technology we are using to make the silk effect and the crystals. So you will print something that is not as silk as this, because it won't be mixed properly. You know, it's there is some research that prove that inside the nozzle, the flow is a laminar flow, so there is no mix. So which means if the filament formula is not compounded properly, it's not mixed properly, then it will be extruded as it is. So the crystallization kind of mess up that mixing. So it will separate the different ingredient we're using. So that's the main reason why silk doesn't have. So we had either we provide a silk filament that doesn't jam, never jam, but doesn't have a good effect, or we trust that nowadays printers are pretty good in terms of managing the heat creep issue, so we can allow ourselves to compromise the jam-free and provide a much higher quality finish filament. So let us know if you think that was the right solution, the right decision. I can see multicolor scientist on the corner. Oh, you mean that one? Oh, sorry, it should not be on the frame. Sorry. That's my bad. Please forget about that one. I think. Scroll down. Which is why only family. Oh, you mean nylon has warp-free, PLA has jam-free? Yeah, Josiah. So that's I think the confusion that Abdullah made. Blah blah blah. I think different print parameters. Santiago. Oh, PLA when crystallized has a much higher. Okay. Thank you, Santiago. Actually, I should read a little bit more to make sure that nobody has answered the question. Then I answer the question. Which is one. I've never understood why there are nylon 11 filament, except for the fact need to melt in nitrogen or something. Sorry, I didn't get it. I think we talked about nylon 11 in the last stream. After it's melted on the hot end, okay, explanation of jam-free. Abdullah, yes, the question back then was actually, does all Polymaker come with jam-free? Blah, 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 blah. Okay, so the answer is no, only our PLA 1.75, and except a couple of them like silk. Loyal Moss, Loyal Moss is here. Good to see you again. We still need to arrange our live stream together. I think we didn't have time to talk about to set up a time yet. Siop, do you have any sample of Polymaker lightweight PLA? Do you mean with me? Yeah, I have. This is the plane made with with lightweight. But if you need, do we have any samples to give away? We do not at the moment. Our sample box only have our previous generation filament, but doesn't have our new generation filament, doesn't have the PLA Pro, the PolyTerra, the lightweight, the CF. So yeah, you know what? Now I have an idea. I'm gonna do a sample box. So we have, on the website, we have a lot of sample boxes, and they are all $19.99 for all the boxes. And then you have boxes with 7 filaments and 50 grams per filament. Then you can try a bunch of them. So I'm gonna make a sample box. Let me know what you think. With PolyTerra PLA, I can put up to 7 into one box, which will be used, the same box as we use for the spool. So I will put a sample of PolyTerra PLA, 50 grams, PolyTerra PLA Plus, Polylite PLA, Polylite PLA Pro, Polymax PLA, lightweight PLA, and CF PLA. And then I don't put the Silk or the Galaxy or the Glow. What do you think if I put these 7? Yeah, that sounds like a good idea, no? I put them into a sample box, and then you guys can just try. You just buy this from our website, and then you have all these 7 different PLAs, and then you can try. If you think that's a good idea, let me know in the comment. Then we can definitely do that. I will ask our product manager, and then we can start developing that sample box. Sounds like a good idea. So Siop, hopefully we'll solve that problem soon of having samples of lightweight PLA. And actually, lightweight PLA, you know what's the difference, right? We have a passive forming, not the active forming that is, for example, from Colorfab or Eason. And there is big differences between active forming and passive forming. I'm talking about this in my in the note I put on the website. So if you go us.polymaker.com and you go Polylite Lightweight PLA, you will have some question. What's the difference between active and passive forming? And then I have a text there, and that's kind of why I think this material is much better, provide higher quality print. And there is a review that I also put there from someone from the RC plane community, and he discovered that material during our Amazon beta testing, and he's an expert in this area. So I highly recommend, if you are interested, to go and check that that review. Sayop, I'm building a 3D printed plane for my senior internship, and I'm thinking of using it. Yeah, like I said, go and check that review, and definitely I think this material is what you need. No, maybe I'm a little bit biased, but I really think, and I can prove it scientifically, why passive forming is much easier to use and provide better result than active forming. Depending on what result you are looking for, because we could also release a 50% or a 40% pre-form PLA. Abdullah, Santiago answered to Abdullah, okay. I would love to see a bottle grade PET recycled filament. I see a lot of promise in it, as it's more like an engineering filament. Yeah, we are working on something similar. Actually, we are working on a huge project, but I think hopefully it will be finished this year. But you guys are going to be all the people that are into sustainability, which I hope is literally all of you. But sustainability is very important, and we have a huge project on this. PolyTerra PLA, the Carbo spool, that was just the beginning. That was really just the beginning. Abdullah, I think they do have sample pack available. Yeah, we do have sample packs, but we don't have all the new generation filament. So because we call that project 3.0 internally, so we only have the 2.0 that is in the sample box. So I need to make all the new generation filament, the 3.0 filament, into a new sample box. Siop, and yes, I am new to the Polymaker filament family. I'm pleased so far and look forward to buying more. Yeah, thank you very much for your trust, and I'm pretty sure you will keep loving our filament. We put a lot of effort in creating high quality filament. We put a lot of effort in developing technologies that would simplify the use of our filament and simplify your creation. My Tech Fun, hello, I just joined 3 a.m. in Hungary. 3 a.m. and you join? Well, thank you very much, My Tech Fun. And I think, I'm very sorry, I think I received an email from you last week. I haven't answered yet, but I will definitely answer. You know that I love your video. I really love the science mindset you put in your video, and I definitely want to continue partnership with you in testing our materials and showing to people scientifically what are the differences between materials and how do they behave under different stress, under different application. So Igor, if I remember well, right? I will answer your email very, very soon. And then and for all the people that are here, please visit My Tech Fun. I think he made I think if you type PolyTerra PLA on YouTube, I think he is the top one review. Why? Because of how well this review is done, how the scientific mindset. If all of you here in the stream really like the scientific way of approaching 3D printing, then My Tech Fun is the way to go. So please go and check out his creation, his work on My Tech Fun YouTube channel. Hello, My Tech Fun. Rewatch your PolyTerra video. Yeah, again, Josiah, like you just mentioned, the PolyTerra video is a very, very well done review. Oh no, it scrolled down all the way. Let me go up again. Where was I? How hard is to print CF? Okay, so My Tech Fun, love your videos. Filament Frenzy, yo Polymaker people, Filament Frenzy. I think I know. Is it Filament Frenzy? Ring me a bell. Is that? Are you a designer making awesome models, or are you the one that collection a whole bunch of filament? I don't remember, but it does ring me a bell. Welcome to our stream. I think that's the first time I see your name. Every week we are nerding around 3D printing, and I'm trying to answer as many questions as I can regarding 3D printing materials in order to share knowledge that we have developed over time. Sayab, how hard is to print carbon fiber filament on a non-enclosed direct drive printer? So CF filament doesn't have to do with the enclosure. So there's the enclosure help with warping, etc. You can go to 2 streams ago where we talked about warping. So CF has only to do with on the printer. It will only affect your hardware. So the extrusion gear, the nozzle, even the filament guides sometimes, any guides on the way. So it's very abrasive filament. So all of this will be affected. So depending the base polymer, the matrix polymer that you're using is the one that will tells you whether you need an enclosure or not. If you are printing, let's say polycarbonate CF, then the polycarbonate will tells you, okay, maybe I need an enclosure because polycarbonate will create a lot of internal stress. So I will have to release that stress and avoid warping. If you are printing with PLA CF, then you don't need an enclosure. But in both cases, Polymax PCCF or, oh, did I just say a new product? And the PLA CF will both require a hardened nozzle and a hardened drive gear. So that's the main thing you need to consider when printing carbon fiber. And how hard it is to print? Not hard. As long as you crank up the temperature compared to the matrix polymer. If it's PLA that prints at 210, then you print PLA CF at 230, and then you will have the same result, a very, very good result. No particular challenges when it comes to having a CF filament. Loyamos, hi Tom. So I guess Filament Frenzy name is Tom. So welcome, Tom. Josiah, I would love to see PA12 CF and PA6 CF and PLA CF in one sample pack. PLA CF is so expensive though. Yeah, PA12, sorry. PA12 is, well, we discussed that topic already between PA12 and PA6, the demand and the production in the world that explain that price difference. But thank you for the suggestion. We can think about a sample pack that are like a reinforced material like PS6GF, PS6CF, PA12CF, and PLA-CF, and all of these reinforced material into one sample pack so that people can try. I would love to see, okay. Chris Polk, my question about composite was your thoughts in general. I always catch insight. I've never thought of the ESD properties. Okay, so I think I did answer the question then. But in general, personally, I'm not a big fan yet of the reinforced material. In the reason why the main reason is we haven't found a very good way to use reinforced material with the additive manufacturing process. Once we have solved that problem, we have a technology that is called fiber reinforced technology. This technology allows the fiber to adhere, to bond much more to the matrix polymer, so that you don't have so much of that non-isotropy difference, like the big difference between the Z strengths of reinforced material and the XY strengths. So if we can push that technology further, and we can take full advantage of reinforced material, but because I do think that's the future, then yes, then I think we'll start to have this reinforced material much more into the additive manufacturing. For large scale printing, for me, large scale printing is all about reinforced material. I think the capability of maintaining dimensional stability when printing for fiber reinforced material is a game changer for large scale printing. I mean, we are talking about we're talking about pallet extrusion. We printed like 50-meter bridge, like some kind of like boat, all of these things. Then we use ASA, glass fiber, PET, carbon fiber reinforced, PETG, carbon fiber reinforced. So in that area we call the BAM, big area additive manufacturing, or MAM, medium area additive manufacturing. Then these already are pretty advanced in terms of reinforced material. So you can check our Polycore. The Polycore family of material is all our pallets, parent materials for MAM and BAM printers. I think there's also SAM, small area additive manufacturing, which is kind of a little bit above desktop printer, I guess. Josiah, should Polymaker PS6GF come in natural? I like the natural color. Josiah, I think I know you like the natural color. Last time you asked about Polymaker PA natural, so I brought a spool for you. So here you go, just for you. Just a shout out to your love for natural, because I told you we are going to end this filament. So I thought I would brought one of the last spool for you to check. But to answer your question, we don't have this in the pipeline at the moment. Natural GF color. Filament Frenzy, saw your tweet. Oh, so Loyal. Okay, so that's the reason. Thank you, Loyal, for sharing our live stream. Nick here is awesome. Tom, Filament Frenzy. Am I only person here to actually not use Polymaker? You do not use Polymaker? Don't worry. We are free here. You can use whatever filament you want. We are here to talk about 3D printing material, not only our filaments. We are here to learn about 3D printing. Josiah, Loyal Moss, Josiah, I'm pretty much almost always use Polymaker filament, better layer adhesion than most. Yeah, I mean, I'm happy if you use Polymaker filament, right? We are trying to make filament that answer the needs of your application, like match the needs of your application. If you have found another filament that match the need, then that's perfect. I mean, at the end of the day, we all want to have the perfect print for our application, and learning from your needs and explaining what our filament are capable. We are trying, the needs and what our materials are capable. And if that plug is already filled, then let's learn about something else. Filament Frenzy can bear a person that talks with knowledge and passion. You can't beat. I thought you said you can't bear a person that talks with knowledge and passion. I was like, oh, that's strange. Yeah, definitely. I'm extremely passionate about 3D printing. I can talk about this. If I didn't have my full-time job here at Polymaker, then I would just stay on the stream 48 hours talking about 3D printing. My tech fan, I joined later, but I can see multicolor printing topics covered, so I can't see. Yeah, I haven't. Usually, I go through the chat and I make sure I answer everything, and then I start the topic. But it's already almost the end of the stream, and I haven't reached the end of the chat. I'm really sorry for that. What I can do is I will add half an hour to the stream. Let's say 20 minutes, half an hour, and then we'll talk about multicolor. So that I still have, let's say, 10 minutes to reach the end of the chat. I will go very fast, and then I will stop the chat, and then we'll talk about multicolor for, let's say, 20 minutes. Blah blah game. I love I've never used. Blah 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 blah. Just like Fuse, slow burn, fast burn. Abdullah fell so much in love with Polymaker that I'm now sole distributor for this brand here. Currently waiting for the first shipment. Oh, really? Where are you based, Abdullah? I don't remember. I thought you were in Canada, or that was my thinking. Loyal Moss, love it. The fewer issues that people experience, the greater the levels of success with filaments. Definitely. Josia, Polymaker should make a filament that is air soluble. Call it resistance-free technology. Air soluble? What's that? That's a joke. Okay, yeah, I guess so. Blah, blah, testing, filament frenzy, right? What was that? I saw rainbow. Yes, I will message you today about getting on your stream. Yeah, okay. Well, I'm very late with my message. You guys are answering some stuff I talked about like 10 minutes ago. I should make filament, blah, blah. Okay, so it looks like the rest have no questions, right? Brian, nice to meet you. Your rainbow filament helmet. Yeah, by the way, Loyal, your helmets are so awesome. Please keep printing them in as many colors as you can. Blah 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 blah. Okay. Polyaqua. Polyaqua is actually something we are really considering for true. We have PolyTerra that plants a tree for every spool. We want to create another one that remove 1 pound of plastic waste from the sea for every spools, and we're thinking about Polyaqua as the name. We talked about this in the last stream, but I really consider that name. I really like it. I'm not a scientist. I'm an artist. I really need to check this filament frenzy. I saw it many times somewhere, but somehow it cannot come back to my mind. Basically, PolyTerra had the layer adhesion ratio and Tom MMU master, no lawyer, blah blah blah. PPCF, blah blah blah. Okay, I'm catching up. When Polymax, PCCF. Yeah, that slipped my. I shouldn't have talked about that one. please forget. To listen to your answer. Okay, I caught up. Maybe a little bit fast. I hope I didn't miss any questions. So let's talk about multicolor printing. So why I want you to talk about this, because I want you to have your thoughts on on how does the future will look like for 3D printing multicolor. Let's try to summarize the current technology to print multicolor, and you can share in the chat as well. For me, there is the first way to print multicolor is to use one nozzle and then put multiple filaments inside. I'm not talking about mixing them, right? I'm talking about, for example, the pallets. from mosaic manufacturing is one way. You have one nozzle, you splice the filaments into different color, and then one nozzle will print those different color, and then will purge itself, and then print the other color, purge itself, print another color. So that's one way. The other way, multiple nozzle. So you have multiple nozzle, and they all have a specific color, and then you use whether you're using a tool changing, whether you have the two nozzle, whether you have an IDEX printer, whatever ways, there is two nozzle, and each of the nozzle have one material, one color. The third one is color mixing. So you have one nozzle, and then you have a CMYK, for example, that goes into the nozzle, and then somehow they push filament together in order to mix them, which, I mean, we just said it's a laminar flow inside, so you would have to modify the inside in order to create, you know, that mixing. But anyway, I think it's called a diamond nozzle or something like this. And then, so I'm not talking about the diamond one where you put one, retract, put the other one, retract. I'm talking about the one that mix them together. Otherwise, that would be the first one. So that's another one. And the final one is you print a material, a transparent one, or that takes the ink, and then on top of that you're printing with like a inkjet, and then it will just absorb that color. So outside of these four technology, one nozzle, multiple filament that goes inside one by one, or one filament that has been spliced, multiple nozzle, whether it's IDEX printer, whether it's tool changing, whether it's the same the same hot end with two nozzle, blah blah blah. And the final one is printing. Sorry, the third one CMYK, and the fourth one is printing with like natural filament, and then having like an inject on the print head that will print on top of that. So is there any other one that you guys are thinking about? I'm trying to think about. I usually don't prepare this topic, right? So I just want to talk about what we know at the moment. I don't want to do like some Google research before and come here and just blah 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 blah. I just want we brainstorm together. But that's, in my opinion, right now, the four types of technology that are used. I own a Polymaker mixing hot end. So that's one that we say. So if there is is there any other one? I don't know what's the lag for the stream, but if there is no, because I cannot see anything in the chat. So if there is only these four, what do you guys think is the future? Do you think the four of them will stay, or do you think there is one of them that will that will win the competition? Basically, of the objective is to print multicolor, to bring that ability to the user. So which one of these four? So let's try to do a pro and cons. The first one using one nozzle, and then you have multiple filament. So let's divide that into two. The first one being the palette way of you splice the filament. The second one being you just push. You have multiple extruder, and then all the extruder push the filament one by one. So I think the palette way, the big pro is you only need one nozzle. You only need one extruder. So pretty much any printer on the market can use this way to print multicolor. So that's one big pro. A con that I see is the amount of color it can take. I think the latest version, I think the V3, the palette V3 can take up to, the V3 Pro can take up to 8 filament. And then, well, actually, no, sorry, it's not a count, because you can have 8 filament that goes in, but you can have another one behind that takes 8 filaments. So at the end of the day, you can have as many filaments as you want. But that can be a count in a way that can increase the price a lot. I mean, it's not a cheap hardware. So if you have to multiply this by, if you want to print with, I don't know, like hundreds of colors, and then you have a multifunction printer, then it can quickly become a limitation. So the Pro, it's very adaptable to any printer because you only use one extruder, one nozzle. The cons is that it has limitation in terms of the number of color you can use. Another cons which I've seen is the purge tower. I've seen a lot of people complaining about the waste of filaments. It's true that if you buy a filament $20 a kg, and you have for a 1 kg print, you have 200 gram or 300 gram that are wasted, then it can, the yield is very low. I think they are working on solving these counts, but that's what I see for that one. Now, when it comes to having multiple extruder into one nozzle, is there any example? Yeah, of course, the MMU from Prusa, I think is using that way, right? Of having many extruder, and then you have one nozzle, and then they just retract, extrude, prime, blah blah blah. So what's the pro? What's the pro of that one? I guess it's integrated into the printer. So let me think. Oh, I know. The Pro is because the palette is doing the same thing. The palette has multiple extruder and then is going into one output. The MMU is doing the same but straight into the nozzle. So one big pros is you have much more control over what filament is going to extrude because the palette needs to do all of this calculation in order to splice the different filament, and it needs a buffer inside. So I guess that's a big pro of having the MMU, is that you're straight connected to the nozzle. And I think the downside is the same as the palette. I guess the downside is limitation in terms of color, because otherwise you have a whole bunch of extruder and maybe the purge tower. I do remember that the purge tower of the MMU is lower than the palette, if I remember well, because it has more control. So that would be, I think, the pros and cons. So quite some limitation. If our goal in the future is to print something with all the colors we want, like multi-jet printing. So then I think there's still a lot of limitation. The second one, multi-extruder with multi-nozzle. So IDEX printer having the same two nozzle, like the Flash 4 Creator Pro or the S3 on the same one. And then what was the third one again? The tool changer. So for that one, I guess there is similar limitation. Is the number of color is limited. Otherwise, you have a whole bunch of extruder or for the tool changer, a whole bunch of tools. And I think, but in that you don't have the downside of having. So the upside is you don't have the downside of having that purge tower. You have way more control over that the color you are going to print. But the limitation is the same. The limitation is the amount of color. And that's why I mentioned the two last one. The CMYK theoretically is not limited by the amount of color. You can put whatever color you want, but the technology is not advanced enough. I mean, I've tried that, and the mix between the color are not good enough. And then there is also a purge tower, to make the mixing. But in terms of color, in terms of future objective of printing things, printing whatever you want with that color, then I think it's something that is closer to the other technology, which are very limited because you need to scale up the hardware as you scale up the number of colors. Rather than this one, you don't scale up the hardware as you scale up the number of colors. You just need to improve that technology. And the last one is the printing. So I think it's XYZ Printing, the Taiwanese company. And I think this is also future-proof, not future-proof, but it's also a technology that brings us a little bit closer to printing something full color. I've visited them during an exhibition, and they could print, they could print packaging with like the ingredients and then the logo, everything. So it was very light, it was not good quality, but the technology itself is something that doesn't have limitation yet in terms of numbers of colors. The limitation for these two is the technology itself. We have to improve that. So that's very quickly an overview of what I think about multicolor, which is very different from multi-material. Multi-materials is something different, which we can talk about in a different stream. But let me know what you guys think about this multicolor idea. This for technology, the limitation of this technology, the advantage of this technology, and what you guys are using now. Obviously, price is also something to be considered, but we always start expensive when we have a new technology, and then we optimize it, we scale it up, and then we make it more cost effective. Okay, let me see if we have some thinking around this. Loyal Moss, MMU Master. So Loyal Moss, you are more onto the second one, right? Having the first one, having one nozzle, many different extruder, and then that purge tower, right? So that's the first one. So we talked about that one. Filament Frenzy, no. Loyal made you, sir, are a living legend. Tom also has a cool accent. Yeah, I will investigating who is this Tom, because I've seen Filament Frenzy somewhere. Where was that? Is that a YouTube channel, Filament Frenzy? Josiah, when will ESD Polymax PTG appear on the website? Soon enough. 2 to 3 months maximum after the Chinese New Year. Printing PPCF on an open Prusa warps like crazy. Yeah, PPCF, PP warps a lot, it's a semi-crystalline, and it will crystallize a lot, will induce a lot of internal stress. So the CF sometimes is not enough to prevent that, or you need a high amount of CF by weight. Josiah, okay, tell me, I've been, filaments, I've successfully printed as fast as my Prusa can go. Polymite PS6CF, PolyTerra, PolyLite ASA. We love to listen to your answers. I'm happy answers can help. If it's called answers, means I answer the question. Because sometimes maybe I read a little bit quickly and then I answer something that is not an answer. I own Polymite Copy Natural Spool. Mixing hot end, multi-tools. Yeah, we mentioned that. So we still have 4. Tool changing and mixing probably will be the front runners. Yeah, tool changing and mixing. Mixing, I agree. I think mixing them means you have access to the whole palette of color. But tool changer is awesome for multi-material. So for multi-material, that's something apart. The analysis I just did is for multicolor. For multi-material, my analysis is completely different. My tech fun multi-tool like Prusa XL will have no wipe tower needed. Okay, but again, multi-tool I think is very limited in terms of colors. Let's say I'm printing 8 colors, means I need 8 tools. If I'm printing a color gradient, how do we do a color gradient with a tool changer? We cannot. I wish to also get a Prusa XL with 2 heads sometimes. I've seen the XL. I think it's a pretty sleek design. I really like it. It was there at Formnext. Santiago, I think better and more affordable multi-tool printer will come soon. I mean, there will be an in-between, right? There will be an in-between where the palette, the dual extrusion, the tool changer, the IDEX printer will be the choice for multicolor. But I think that short term, if we really want to develop that additive manufacturing to to its full potential, we definitely right now need to work on a better technology, something that can scale up much more. You know, if you have a 2D printer, can you imagine a 2D printer? You need to add a cartridge every time you need a new color. Well, that's impossible, right? I mean, maybe at that time they had this, I don't even know, but they quickly had to develop a technology that you can have the full palette of color without having a 1 kilometer 2D printer, right? So in that perspective, I think that we're very far yet from multicolor printing. Another answer is this one: FDM will never be the solution for multicolor printing. It will be multi-jet printing, for example, or it will be multi-jet. So right now, I think that's the one that do the job. But let me know what you guys think. Do you think FDM has a future there, or no? Do you think we will never find a technology that allow us to use the FDM technology with the full color palette? Josiah, I should make an IDEX printer sometimes after my high speed, high temp industrial style one. Oh, so you're building a printer, a full industrial high speed? I feel like laminar mixing hot end would be good, making a quadrant per color. Yeah, definitely. I think, again, color mixing and printing with ink on top of the filament are the one that I think would be successful. But let me just take a small break here. Another thing to mention is injection molding. What's the idea behind injection molding? Because definitely they cannot injection mold multiple color, right? So they just decided injection molding is not for color printing. It's not for molding some different color. They just injection mold them separately, and then they assemble everything. And then they also have injection molding and then some painting process. So injection molding solved that problem by not having it. They just decided that's not a technology for multicolor. So is that gonna be the FDM answer? Is the FDM answer printing in one color and just improving the post-processing, improving having a smooth finish, and then we can just paint them or put some stickers or whatever? So is that gonna be the answer for FDM? We will just get stuck at 8 color maximum, and then that's it. You just choose the 8 color. That's going to be one of the biggest limitation of FDM. You cannot use the whole palette of colors. That could be another answer. I feel I pretty much will use multicolor printing for multi-material printing to improve parts and make them cheaper. Yeah, multi-material, we can do this analysis of the multi-material technology on the market in the next stream. That's another interesting one. Actually, much more interesting than multicolor, but it was just to warm up a little bit. Blah, 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 blah. My school has these Tinkeran Ditto Pros, and sometimes I feel like what if I made a printer for a chip that can safely print PETG and ABS with MMU? Also, multi-material interests me. Yeah, multi-material, we'll talk about this after. Super Slow, welcome. Super Slow, yes, you were there in the different stream. I always remember that name. Welcome back to the stream. A little bit late, we almost finished the stream, but thank you for joining. Chris Paul almost finished the stream, but thank you for joining. Chris Paul, I would love a full stream about palette extrusion technologies. Okay. It's a little bit less in line with what you guys are using, but if you are interested into palette printing, we can do. There's a lot of technical stuff about the different problem about for example, how do you do retraction with a screw drive palette printer? and then there is some technology, some solution that has been implemented. So how do you print in a heated chamber? How have we solved the problem of printing that 20-meter bridge? All of this. So yeah, why not? Let's try to do that in a future stream, talking a little bit more about BAM and MAM, big area additive manufacturing. And maybe I will invite one of our experts. We have an engineer expert into big additive manufacturing. Maybe I can invite him on the stream for like 20 minutes, and then we just he will give you a presentation on this. We have Race 3D Pro 2 and Race 3D E2 machine multi-nozzle. Yeah, most of them are multi-nozzle. I think the main purpose is for multi-materials. I mean, it's great to have dual color, but I think the engineering process is we need support material, we need multi-material, and then then you can do two color. But I don't think the thinking process is, what if we do multi-color? Let's do two color, and then let's do a dual extrusion. So I think printing dual color is just a side advantage of having that additional support nozzle. But I don't think the technology was towards printing multicolor. Josie, I was wanting an MMU, but I've heard it's not very reliable. So MMU might not be for me, and I use a tool changer instead. Yeah, MMU, I mean, the MMU, you have to really handle that all of these retraction, and it can clog very easily if you don't manage that very well. The tool changer, you completely change the tool. So obviously, my guess is that it's much more reliable a tool changer than the MMU. But the MMU is, I mean, Prusa Research, the company, these guys are high quality guys. This guy will make things, will release something that works like tested 100 times already. So I'm surprised that you say the MMU from Prusa is not reliable. I do have very good experience in talking with Prusa guys and touching their hardware. So I guess they should have made that MMU reliable. I think, yeah, I don't know. Maybe some other people that have MMU can comment on that. Lawyer Moss, IDEX printer. Yeah, IDEX printer is pretty nice. I think IDEX printer is the same. The idea behind was more, to not have to have support material, and then the side advantage was that you can print in two colors. I think multi-material, and by the way, the IDEX printer advantage is the only advantage is not the only advantage, but why we came up with IDEX printer, my guess is because of the oozing issue. I don't see other reason why we would develop an IDEX printer except for this of not having that other nozzle oozing everywhere into your print. And I think the dual, like when you print in mirror, you print two in mirror, I think that's more a side advantage of having that IDEX. I don't think in their mind they designed the IDEX by saying, what if they could print two things at the same time, something like this. I think the way of thinking was a little bit different. I think multi-material is the goal. Multicolor, you can always paint it. Yeah, that's my thinking. I don't think we can push the multicolor technology to a certain extent, but I think at the end of the day, we better focus on the post-processing. Similar than injection molding. I mean, at the end of the day, we can even use all the injection molding post-processing way of making a multicolor part instead of reinventing our own. So that's my guess, but that's just a hypothesis. Super slow. I think my leading desire at the moment is an IDEX or simple tool changer with support material in one and ERCF, MMU on the other. Yeah, again, that's more for multi-materials. So, well, at least you guys are also in line, right? The multi-extruder, the dual extruder, tool changer is really about that multi-material instead of multicolor. I haven't seen anyone that said in the chat that said I bought that printer, dual extrusion printer, because I would be able to print 2-color prints. Or if there is, please let me know. My tech fund, 2 extruder, 1 nozzle, more waste material, but no need for 2 nozzle calibration. Yeah, that's a good point. Calibration is also something to consider. If you have a tool changer, I guess you will have to have them calibrated very well. If you have a dual nozzle, you will have to have them calibrated also. Rather than if you have 1 nozzle, then it's much easier. 2 extruder, 2 nozzle. The cons, it has to be calibrated in XYZ direction, yes. Or we have a color offset, common problem on chip printer, but less waste material. Yeah, definitely. But again, two color, is that really, when you think about it, 2 color is nothing, right? It's like I don't know. I mean, it's better than 1 for sure. It's a big step from going to 1 color to 2 color. But once you are at 2 color, 3, 4, 5, 6, I don't know. It's I don't feel that 2 color is a big advancement when it comes to multicolor printing. I would love to see a stream on multi-material printing. Yeah, we can do a similar analysis for multi-material. Same with palette printing and palette extrusion. Okay, tool changer are a game changer. Tool changer are a game changer. I don't know. Tool changer. I mean, tool changer. I will keep repeating this, but I don't know. It's great. Is that a big innovation? Tool changer. Having an arm that go and pick stuff around and then pick a tool, use that tool, pick another tool. I'm only just now starting to play with an IDEX machine. Yeah, I'm wondering, is there IDEX machine that use more than 2 hot end? Micro-active mixing would be mandatory for multicolor with actual gradient, but the mixing chamber creates a lot of waste, pending slicer support for printing extra part that use the waste color. Yeah, that's very true. Maybe in the future, Santiago, maybe in the future, we will print the thing out of a material that then being hit by different laser frequency will acquire a different color. Yeah, this kind of thing is for me innovation, thinking out of the box. Like what can you do? I mean, I've seen this idea in a research paper, but taking all of this out of the box idea on multicolor, like really fixing ourselves into what's the future of additive manufacturing when it comes to multicolor for FDM. What are we going to do? What's going to be the next big innovation that's really going to help us achieve that goal? Corey Newhart, is PLA Pro plant-based like the PolyTerra? Yes, Corey, I think you're new to the stream. Welcome to the stream. So PLA Pro is PLA-based. Any PLA, PolyTerra PLA, PLA Plus, Polylite PLA, Polylite PLA Pro, Polymax PLA, all of them are PLA-based, and PLA is produced from the atmosphere, creating that lactic acid chain and then polymerizing to a polylactic acid, which is PLA. So yes, any PLA based material is plant-based. By the way, I highly recommend you go in our last stream. You can skip the Q&A part and go to the reality behind PLA. Is being plant-based really eco-friendly, etc. So we had some to the reality behind PLA. Is being plant-based really eco-friendly, etc. So we had some good topic about this. Corey Newhart. Santiago, like they make the newer color filter for screens. Like they make the newer color filter for prints. Sorry, I don't know that one. My tech friend Brian, do you use Cura? I noticed the problem with Wipe Tower, Prime Tower. Yeah. By the way, maybe Cura, Simplify 3D, Idea Slicer, all of this. We could do a stream where we dive into all of the different settings they have. They sometimes have some settings that are, in my opinion, very interesting that people sometimes don't really use. or some setting that you can use them, but not for the purpose they were intended to. Josiah, imagine a printer that use cantilevered x-axis for two head that could move freely on XY, kind of like portal style. Yeah, sorry, I don't know that word. Maybe if you have the French version. Continuing the previous message, less build volume restriction. Most PLA is plant-based. Santiago, yes, correct. Corey, but is it biodegradable? Just question I've been thinking about. No. Yeah, actually, just go to the last stream. The last stream we made a whole part on the biodegradability of PLA. What do we mean by biodegradable? What do people think about biodegradable? The short answer is no, it doesn't biodegrade in a way that people think. Yes, it has biodegradability properties that can be used in order to improve the end of life of PLA. So that's the short answer. That's like the 1 hour stream of last time into a 10 second. Brian, my tech fan I'm using, blah, blah, okay, answering to my tech fan. What about bio PET, bio PP? Yeah, I think we talked about this, Josiah, in the last stream. Especially the bio PET. Josiah, the previous stream is about that. Yes. Blah blah blah. My tech fan answering to Brian. My tech fan. Two colors are important because you can have supports in PVA to dissolve away in water. Well, that's the thing. I don't know. I think you're talking about support material. Then that's two support. That's two different material, not two colors. Or let me read again. Two colors are important because you can have supports in PVA to dissolve away the water. Yeah. I think there is some misunderstanding there. I'm talking about multicolor, like the same material but a different color, not multi-material. Again, multi-material, the analysis is very different. But for multicolor, that's where I am right now. But the stream froze for me. Oh, is there a problem with the stream? Anyway, it's almost finished. I don't know if there's a problem with the video. Upgrading my Adobe Flash thing. Might take two materials. My stream froze too. Stuck on Flash thing. Might take two materials. My stream froze too. Stuck on pick a tool on an infinite loop. What? I guess still there. My stream froze. I do some stuff with business logos that I use two colors. Had good luck doing easy filament change with PETG on my Ender 3 Pro. Haven't tried the workflow on Voron yet. In ASA, not looking forward to it. Okay. Yeah, I mean, two colors for certain application is good enough. Another joke. If there is jam free, does that mean if I buy Polylite PLA, it doesn't come with jam on it? Does it repel jam? So you're into joke, Josiah? Thank you, Nicholas. Thanks, guys. Maybe we should do the topic, then question. Yeah. Sorry. Next time I will do the topic first and then the question, so that people that are interested in the topic just watch the beginning, and then I will just spend time on the answer in the end. I will do that in the next stream. I will start by the topic for sure. Cantilever is like the Prusa Mini hanging on one side, supported just. Okay. Yeah, I get what you mean. Like the monoprice Mini, right? Also, what's the ding ding sound from? Yeah, maybe that's my because I'm supposed to be working right now. It's already half an hour of the stream. So I got a lot of message. Also, what's the if someone ever going to make an easy to print order free modify Delrin filament? I don't know what's that. Polymaker should take on IGUS and make Tribo Plus, but printable on having layer adhesion. Well, Josiah, you use some words that I don't know. Super slow on having layer adhesion. Well, Josiah, you use some words that I don't know. Super slow. Darren, watch Chuck Bryan try to print with it, blah, blah, blah. PTFE filament. Oof, that would be hard. Okay, I caught up on everything. I'm sorry for the people that came for the multicolor analysis or my thought on multicolor and had to wait the whole Q&A. So what I'm going to do next time, I'm going to first spend 20 minutes to 30 minutes on the topic itself, and then you guys can share on the topic. So make sure that you don't ask questions before that, because I won't scroll back on the chat. And then after that, then we can start the Q&A session. Then you can ask anything you want, and then I will just spend time on answering them. So let's do like this. Let's do like this. 526 5060. Yo, Polymaker is the dopest filament company out there. Keep it up. Thank you very much. I think you are new to the stream. Thank you for dropping that last line before we are closing the stream. That's very nice to hear. Again, so we are closing the stream. I think we had very good discussion. We had very good Q&A, talked a little bit about what we think about multicolor printing. Please share your question on our Reddit community, which is down in the description. You can share your prints. You can share your troubles you have with 3D printing materials, and we'll try to talk about this in the next stream. So we are streaming every Thursday, 8:30 EST, and once a month we have a more EU-friendly time, which is on Saturday evening for me, which is Saturday morning for you guys. But stay in touch on our social media so that you know when we are going live. Thank you very much again for joining, and I see you guys next week.